Okay, and that was the high sign, and that means I am on. My name is Dave Frederick. I'm Senior Director of Product Marketing for Quantum. And I'm not a scientist. I don't even play one on TV. So if you ask me a question that I'm not able to answer, I'm going to tell you that I don't know the answer, but I have people here at the show who can. So we'll get you over to the booth and we'll get those questions answered for you. This is going to be a nice, relaxing session. We'll spend about 10 or 15 minutes talking about tiering and the implications of tiering in general, and also some implications of tiering in a virtualized environment. So I hope this is a topic that is of interest to you, and we'll be going through it on a number of different levels. Obviously, the reason to tier data among different storage platforms is both to optimize performance and also to optimize capacity. And I know that some of you here many of you may not have all of the resources that you would like, and I'm sure that if you had the money, how many of you, if you had unlimited money, you'd run everything in Flash all the time, you'd never touch spinning disk in your life, right? There you go. I'm getting people way out in the outside too, that's good. So if that were the case, if you could get the best possible performance from your disks at all times, and you could afford to do it, tiering wouldn't be an issue. You'd put everything where you want it and it would run great. But it is an issue because we can't all afford to run everything in Flash all the time. So we need to optimize performance and optimize capacity based on our ability to pay for it, because performance is expensive and capacity is less expensive, but it still does cost money. So let's talk about a couple of different types of tiering. You may not even you may have arrays that you aren't even aware that you're actually tiering, because the tiering is happening internally. And if you look at this diagram here, for example, this is an example of an array that is doing once per day scheduled tiering between hard disk and Flash. So what's happening is the data comes in, it starts to get used, some of it is active, some of it's cold, and it starts to separate itself out into things that people are really using a lot of and things that people are not particularly excited about. And so at the end of the day, that's all calculated based on usage logs and then migrated to Flash based on what was active at the time. Now, and this is good. This is a good approach for fairly static data. You know, if you're dealing with stuff that's not changing, or if the workloads in your organization aren't changing that much, the same data is being used on an ongoing basis, for example, this can be an effective use of tiering, and it's usually slower. It's computationally expensive, so people don't want to have this happen at peak times during the workday, and they typically let this run overnight, late at night, when only your best coders are working. So now there is another type of tiering, which is real-time tiering. Let me show you that. This happens on a much more frequent basis and is typically done with some type of algorithm, like a heuristic algorithm, or even a check of the type of data that's being stored at the time. And if that type of data is particularly well suited to being in Flash, it will steer the data toward Flash immediately. So in this case, every 5 seconds, the system is taking a heuristic view of the data on the drive and migrating, tiering, if you will, among the different tiers. This particular example is an example of that we follow with our QXS storage at Quantum. And that storage can support 3 different tiers. We automatically tier between the 3, and we do it both on usage changes and also on ingest. So if that's something that you have an interest in, we can talk to you about it at the booth. I'm trying to stay non-commercial and non-marketing here as much as possible. So just to, when you're looking at an array, that tiering that goes on in the array, you've spent a certain amount of money for that array, but you also don't want to have to overbuy too much Flash. And it's possible, for example, with the QXS system, with as little as 10% Flash, we can get over 90% of the IOPS from Flash. So just by doing some intelligent management of the data in and out of Flash and disk, it makes it a very efficient machine that can cost a half to a quarter of what a Flash array of that kind of capacity would require. So it can be a great choice. You should always check for your tiering architecture in an array, for any array that you buy. But what about data that's on a broader scale, outside of your a single array, and as you move out to your broader environment? Well, we'll go a little bit high level again and talk about why would we tier between volumes, not just within a volume. Well, one of the reasons is you usually want to have your highest performing workloads or your highest performance requirement workloads on your best performing disk or best performing tier of storage. And on the left here, we would have our primary storage, and that's where we're going to put our most important jobs and our most important people working on those jobs. But what happens when that starts to get filled up is we're constrained to the point where it starts to affect performance. We need headroom in capacity, and we're not able to manage the amount of storage we have effectively. So by tiering data off to a second lower cost tier, and if you do it intelligently where you're moving the data that's not so actively used, you can actually move from a higher cost tier to a lower cost tier and get quite a few benefits. One is you're going to release capacity and essentially release capabilities into your organization by allowing them the freedom to have more of that primary disk. So that high performance primary disk is a high value commodity, and you want to use that as efficiently as you can. So this model of archiving or tiering off to a lower cost tier is one way of freeing up that high performance disk. Not to mention the fact that you're just freeing up space. So you've got space to work with, and we all know that systems tend to run better when they can move files around and access data more quickly when there's more space around. The other interesting aspect of this is so from a performance standpoint and a price standpoint, it's like getting free disk. So whenever you tier off to a lower cost tier, if you look at the capacity that you're moving and take the difference between the price per terabyte of that storage device and the price per terabyte of your primary storage device, that's your return on tiering. And you get that every time you tier data efficiently. So now, obviously, one of the key attributes of tiering efficiently is being able to get to the data that you're tiering off. Otherwise, you're not tiering, you're tearing, or just tearing it up, because you're putting it away where you can't get to it. And that's not the point. The point of tiering is to have continuous access to the data and still have it live on a lower performance, lower cost tier. Now, a very common activity in the virtualization space is backup. And backup is a kind of tiering. You're tiering off a safety copy of data, but it's important that you work with backups in a similar sort of format where you're thinking about the maximum utilization of the disks that you're going to. And in the case of Quantum, we offer a deduplication appliance that's specifically made to maximize the amount, or actually to minimize the amount of space that your VM backups take up, and allow you still to have the performance required to have access to those backups. And we'll cover that a little bit more. But in this case, as you're backing up the data, we're deduping that data in real time and putting it in a very small fraction of the space that would otherwise be required. So this is a common activity. It's probably no surprise to any of you that goes on. What's interesting is when you start to look at a hybrid model of archiving by tiering and also backing up. And this is where you start to gain additional benefits that you may not have considered before. So in this case, the primary storage is going to be backed up to the backup storage. We'll be deduping that data so it gets very small, and incremental backups simply get added to that, and we can read from any restore point that we want. Okay? But if we go ahead and look at some of the aging data that we don't need to back up on a daily basis and move that over to a third tier, a lower cost archive tier essentially, then we've freed up primary disk space and we've reduced the size of our nightly backups or our 3 or 4 times daily backups, whatever your frequency is. So now you're backing up less data, so network traffic is reduced. You're backing up less data, and depending on the pricing model of your backup software, the cost of backups can go down. And you've improved the performance of your primary disk, and you got free disk space back. Okay, so it's really the best of all worlds. And you can still even apply this to the backup storage. If you look at the center block, now we start to back up the archive, sorry, the backups. We're going to move it from, let me get a pointer here. I don't have the pointer working. Is this working? Oh, it just doesn't show up on the screen, sorry. So this middle column here, we can also use this as a source for tiering. So as backups age out, you may have legal requirements that force you to keep them around. Your retention policy may be longer than the life of a VM and its backup. And so we also want to be able to tier those off to archive storage and get even to a lower price model for the backups. So these could be managed as direct archives, as you see the connection from primary storage to the archive storage. This would be done through vCenter or the hypervisor interface, or it could be managed by a backup solution like Commvault or Symantec or Veeam, someone like that. So in the case of Veeam, at the show, we're highlighting a particular solution that includes the Veeam Instant VM Recovery and Veeam Explorer functionality in conjunction with the DXI deduplication appliance. And it gives us some unique capabilities. First of all, the DXI runs deduplication to 95% efficiency. In other words, 95% of the data is reduced. And it does it in real time, so it's very fast. But by having Veeam manage that backup, we can also retain visibility through Veeam and offer them the ability to browse those backups, and also to instantly load a VM and run it on the spot to see if that's the VM that you wanted to work with, even before you go through the process of restoring. So the DXI does a reconstitution of the data in real time, just the same way it does a deduplication of the data in real time, and allows you to browse and preview these VMs while they're still in backup. And that's just a huge advantage. This is all policy-based, so you can establish the rules by which your VMs get backed up, and you might have overlapping rules that allow you to create multiple backup locations for particular VMs, and they can happen at different intervals and different refresh recycles. And this is an example of how the Veeam Backup DXI combination can work in a larger tiering environment, where we're actually taking these backups and we're further tiering them off onto other locations. And these locations could be it could be additional storage in the form of disk, it could be tape, or it could be cloud services. So, when you're talking about tiering to a long-term storage environment, you really want to think about all of your options and all of the costs associated with those options. Now, I have about a minute left, so I just want to quickly introduce you to another form of multi-system tiering, and that is really one of our core products, which is StoreNext. StoreNext is a shared file system, and many people know it as a very high-performance streaming file system, but it also includes a global namespace manager, a policy engine, and a data mover. And that turns it into not only a shared storage environment, but also a tiered storage environment. So when we're working with customers that have large unstructured data pools, and they're moving these around in real time to get them from one pool to the other, to have different parts of the workflow being addressed, that's where we come from. This is our pedigree, is being able to run entire operations within a tiered shared storage environment. And I'm going to skip over the product line, but I just want to leave you with Quantum's core concept and core tenet, which is always keeping data in the right place at the right time based on cost, performance, and access. And if you're thinking about your data storage in those terms, if you went back to your facility tomorrow after the show and said, where am I costing myself money by storing data at too high a cost, and where are my opportunities to move data down to a lower cost tier, I think you'll find some opportunities to save some money and maybe even get some free disk back. Okay? So thanks very much. I've been Dave Frederick, and you've been fabulous. So appreciate your time.